Hello everyone, this is a video tutorial on solving a problem related to gravitation and movement of objects, or let's say bodies in a space. So here we have the question. A heavenly body weighing 3 into 10 to the power 24 kgs revolves around a star whose mass is 4 into 10 to the power 30 kg. They are positioned at some positions, and the heavenly body has a velocity of something meter per second at a particular instant. What is the momentum of the body after a month? So we are calculating the final momentum of the heavenly body which is revolving around the star in a month's period. So let's begin. Firstly, what we need to find is we need to find the distance between the bodies that are the star and the body. Since the force is exerted by the star on the body, we have to calculate the radius, which is equal to radius of the body minus radius of the star, which is to say the position of the body minus the position of the star. And as we calculate that, we get a vector quantity, which is the radius, that we get 1 into 10 to the power 11, 2.5 into 10 to the power 11, minus 2 into the power 11 meter. But let's take that note that this is not the radius. This is just the vector quantity. We need to find its magnitude to get the actual distance, which is the radius between these two bodies. So what we do now is we take the magnitude of the radius that we have already found by subtracting the position of those two bodies, and what we get is 3.35 into 10 to the power 11 meters. Now that is the distance between these two bodies. After doing that, we need to find the magnitude of force along with its direction, which is given by F is equals to m1, which stands for the mass of the heavenly body, times m2, the mass of the star, divided by radius, the magnitude of the radius, and then multiplied with the negative r cap. We will be discussing why the negative in the next slide. So here r cap means the unit vector of r, the distance, which the r is the distance, so r cap is equal to r vector divided by r's magnitude. Now since we have already used the minus, let me take a moment to explain why the minus we used. The minus is since we are taking direction of force on planet. We're not taking the force of the planet on the earth, but we are taking the direction of the force on the planet. So which is why we use a negative sign. So we do that and we calculate our F, and we get negative 2.14 times 10 to the power 21, negative 5.34 times 10 to the power 21, and the G component 4.27 into the power 21 Newton. And now that we have to find the initial momentum, we have the mass of the body and the velocity, so we multiply mass and velocity and get the momentum. As for time, we have a month's time. Now that month has to be calculated into seconds so that we can get the units right. So a month has 30 days, times a day has 24 hours, times every hour has 60 minutes, times every minute has 60 seconds. So doing that, we get 2.6 into 10 to the power 6 seconds. Now finally, we have to calculate the final momentum, which is P final, and that is given by vector quantity of P initial plus the force that we have already calculated between those two bodies and the change in time. So calculating that, we get our final momentum, which is negative 5.56 into the power 27, 7.62 into the power 28, 1.11 into the power 28 kg meter per second. Thank you.